Today. So let's go ahead and give it up for Rick with the opening talk.
Thank you, Tab. Okay, I'm going to try to talk about regression prevention and mitigation or incident response. And this is something, I've long been a passion of mine on the Chrome team. Maybe I should say Rick Byers worked on Chrome for 14 years, various different roles. Today I play an area tech lead role, and part of my job is to help coordinate across the Chrome engineering team, in addition to the Chromium project, on improving quality. And so that's some of what this is about. There's a ton of people that work in this space. We've got for example, we have a big engineering productivity team that includes people like Vivian and others who are here who have more of the details. But my hope was to give a high-level overview of this space and spark some discussion. And then those of you that are really passionate and want to dive into how we can work better together in the Chromium project to improve quality, please join me afterwards for a breakout session. Hopefully we don't overflow the room. Okay, so we have kind of two conflicting goals, I would say, in Chromium. We want to make the web reliable and trustworthy, but we also want to move the web forward. And these are in some tension. I worry a lot about stakeholder sentiment of the web. Can your business really afford to bet its business on the web? What does it mean for you to bet your whole business on the web, right? We heard a little bit from NVIDIA yesterday. I thought that was really fascinating, hearing about even having a couple days of an outage, how disruptive that can be. So, I think that's critical for us. But at the same time, we don't want to be paralyzed by fear. And, I've worked on some other projects in my career where, it's well, reliability is so important that we basically have to grind our progress to a halt. And so we always are trying to balance these two things. And also an important aspect of this is engineering velocity, right? If we want to actually be able to move the web forward, we can't be bogged down in too much bureaucracy and all sorts of stuff that really just serves to slow us down in trying to get things done. So, but the good news is I think there are win-win trade-offs that exist between this. This isn't just a turn the dial between moving faster and doing more versus being more careful. We find engineering is all about finding the win-win solutions, and we've got a lot of experience with this. So I'm hoping to chat a little bit about that. Trade-off. So I thought maybe the way I'd structure this is just think about, I've looked at a lot of the different incidents we've had over the years, and there's a lot of stages in an incident and when things go wrong. And the sad thing is, for things to go right, it's you can afford one of these steps maybe to have some problems, but it's for the most part, at every single stage, things have got to go right or you're going to have a disaster, right? So I'm going to walk through the talk kind of at each of these 10 stages and talk about what are the tools we have to help us do a better job at this stage and reduce the risk of having some outage or incident or some problem, and what are the ways that goes wrong. And I'm going to try to share some examples, and this some are good examples, some are not so good examples. This is all in the spirit of us learning together. Critical to what we've learned over the entire history of Chrome and the Chromium project is that we have to take a critical eye and reflect on what we can do better, but in a blameless way. So you'll see in some places I've obscured some names and whatnot, just because the goal here is not to point fingers at people for making mistakes, right? We all want to acknowledge the mistakes that we've made and then learn from them to try to build a better product. So, okay, first step is, in any incident, the first thing that happens is somebody lands a regression, right? Something gets worse. I mean, I shouldn't say any. There are complicated cases where this doesn't happen, but for the most case, somebody's landing some change that causes a problem. And we have lots of things at this stage to try to prevent there being a problem. The best case scenario is that somebody writes some code that has a regression and it's caught in code review and never lands, right? So we got to always remember, let's go back to that phase. What do we have? Everything we do around code review, right? We have this really high culture in Chromium of intentionally slowing ourselves down a bit to double check every line of code that we add. And we think that's a good trade-off. Sometimes we go too far. Sometimes you're getting 10 different people to look at some line of code that doesn't need 10 people looking at it. We got to do better on that. But in general, I think a lot of what you're all used to doing in your day-to-day working on Chromium is critical here. And there's lots can go wrong, right? One of the key things that I think a lot about is just the complexity of the code base, right? The harder it is to reason about code, in particular, the more it requires global reasoning, the more for you to reason whether this is going to cause a regression or not, you have to understand more than the code you're looking at. You have to understand 27 different subsystems and how the memory management works across all of them, right? The more likely that you're going to introduce a regression. So this is where you see us doing things like miracle pointer, or, you know, in some places we're rewriting some things in Rust, or, you know, we're encouraging more invariant enforcement, right? When we use, you know, we have not reached, and we encourage more use of checks and not reached, right? That's all about trying to reduce the chance that you are going to introduce a regression later that turns into a major incident. There's a couple other tools that are maybe worth highlighting here in case people don't realize. A lot of our incidents, especially for those of us in this room, web platform stuff, a lot of our incidents come from unintentional changes to website behavior. And so hopefully you're familiar, you know, we have some extra checks and balances here. If you accidentally remove an API from the web, for example, the stable web expose tests are going to fail, and you're going to have to get a LGTM from an API owner to be able to do that. That's to just help enforce our break and change process. But all these are heuristics, right? And there's a blurry line between what's a bug fix versus what's an intentional change to the web. Anyway, lots we could talk about here. Lots of ways that this can go wrong. Here's an example. This was kind of a fun one. We shipped a new API called window.report. You know, normally shipping new APIs, you don't think of as being breaking changes. But this one, luckily, we had enough experience to know, oh, adding an API called report, you know, on the way JavaScript works, the way the web works, that actually could be a breaking change. And we did a little bit of analysis. And I screwed up in this one in that I did a HTTP archive analysis looking for uses like, you can imagine JavaScript that says, if report in window, do something, right? And then when we add report to window, that breaks it. That analysis told us it looked really safe and we should try it. One thing I screwed up on here is we didn't have a kill switch for this. For technical reasons, we had to just land it directly in the code. So once this caused a problem, our only option was to land a code fix. The problem was I didn't even appreciate one way that this could break. It turned out SAP Business Objects, which is, you know, used very broadly in lots of enterprises, had code that had iframe name equals report. And then they had code later that said window.report something or other to refer to the iframe. This is a very legacy style of, you know, it's explicitly discouraged in the HTML spec to rely on this for exactly this kind of reason. But it was in SAP Business Objects in a way that just totally broke this product that's used across a large number of enterprises. And I think we didn't hear a thing about it until like 2 days after this hit stable. And we had this flood of people saying, oh my God, my business is horked right now. What are you going to do about it? So this was kind of an interesting. Now, luckily in this case, you know, it took us 4 days, including over a weekend. It's a little longer than I would like, but, you know, to bisect, to understand what the cause of the problem was, triage it, revert it, merge it, and deploy a new stable release of Chrome to fix this. Could have been worse, but still, I think could have been better. Okay, the next stage is after there's been a regression, just do we even identify that there was a regression? And in the best case, this is where like we want to optimize, try to figure out how do we get more of the best case scenario. The best case scenario is that we don't actually need a human to identify. We don't need somebody to file a bug and say that there was a bug here. Best case, we have telemetry coming back telling us there's a bug. This is where, you know, for a lot of Chrome's history, we've relied really heavily on our release channels, Canary, Dev, Beta. I think those aren't quite as helpful as they've been in the past. We see a real bias in the types of users who use beta. So I see a lot of incidents that just nobody ever seems to notice in beta. Lately, Chrome has started to do what we call an early release or early stable, where I think it's a week before stable release, we send about 1% of our stable users to kind of the last beta build, basically. That's been really helpful. Especially, it's been helpful for our crash and hang reporting, right? That gives us real telemetry that tells us once we start rolling out the stable, and we roll stable up gradually, also for this reason, what can we expect? And then we can do analysis and say, oh, we're starting to see a few crashes here at 1%. When we turn it up to 50, you know, we can extrapolate. Oh, this is going to be a big crasher if we turn it up to 100%. This is a release blocker. We need to get this fixed. And we have a lot of other things we've tried to do with telemetry. You know, we have, and by the way, I should have mentioned, I know this is a Chromium community. I'm intentionally talking about a bunch of what we do at Google Chrome because that's not something we normally do in this forum. And I thought it was useful to share the mix of stuff that's Chromium open source and also Google internal. And then we can brainstorm about, hey, some of this Google internal stuff, should we figure out ways of sharing this more between, you know, Microsoft and other downstream browsers? Or, you know, let's talk about what's the right mix between what's the open source project versus what's the Google product. So I'm sure you've heard of like Google has these systems for telemetry called UMA and UKM, right? They're generally available only to Google employees for data privacy reasons and that sort of thing. But sometimes they can be super useful. It's possible for people to set up. Actually, sorry, that's on another slide. Let's see. But there's all sorts of things that can go wrong here. One pattern we've seen, for example, is we know that enterprises are more likely to disable some of our telemetry. We've tried to improve that over time by giving them levels and saying, well, maybe keep crash reporting on, but maybe disable most of our UKM type stuff. One kind of nefarious one is web compatibility is always a challenge, right? Where's the line between where you can, you're fixing a bug, versus breaking the web, and it takes a lot of judgment and experience. So here's an example I wanted to share. Oh no, sorry. Sorry, that one's coming next. A little rough, but yeah, so we're still on issue identified. So here, this was one, right, this is one that probably a lot of people don't realize. A real valuable source of identifying issues that we have is our feedback system, right? In Chrome, as an end user, you can go to send feedback and write a human response. And this tends to be end users, they tend not to be developers. So it can be very noisy, but then we have a whole team and a whole system that tries to group those reports. And then you might see bugs like this get filed that say, user reports missing password, user reports of something where a human has gone and looked at a cluster and said, oh, there's an interesting pattern here. And this is one where we didn't hear anything in beta, but for the 1 week we had of early stable, we had enough feedback reports of a few users saying that they were missing passwords in the password manager, that we're able to get a bug filed, saying, hey, it looks like there's an anomaly here. We should probably act on this quickly before this goes to stable. And this was one that, this could have been really bad. We were lucky that we caught this in early stable before we started ramping stable up to 100% of users. Okay, and then there's what we think of all the time in terms of instances, like when does a bug actually get filed on Chromium? Obviously, all of our incidents go through our bug tracker. Mostly those should be open bugs. You should be able to see them most of the time. The best case here is a bug gets filed that's actually detailed and actionable. And so we do a lot to try to help increase the chance of that being the case. We've got a new bug wizard. If you go to create a bug without being a project member, then you'll get this template that kind of guides you through filing a Chromium bug, and it asks for things. Here's how to write a, reproduction, please give us reproducible information. Again, it's the best case is we don't even need to rely on humans for this. So one system I really like is the crash auto bug filer. We get these crash reports, and then we will automatically, the system does a really good job of analyzing the patterns of crash reports and trying to identify which crash reports seem like, suggest that they're a new incident, and then automatically file a bug and try to get it routed to the right person. What else? There's lots of challenges here. One thing that we fought against for a long time is this sentiment of people feeling like, it's not worth me filing a bug. Either someone else is going to file it, or if I file it, it's just going to be ignored. So this is why, I think it's really important that when users take the time to file a bug against us and tell us about a regression, we really got to invest the time to thank them for that. It's a gift they're giving us. They're buying us time in an incident. And every single one of those to me is like a practice run for, how we respond to this. We can't predict always in advance. Is this going to be a big disaster, or is this just going to be one of these, small blips? And so I see every time somebody files a bug on us and says, you've got a regression, I treat this could be a big one. Let me thank them. Let me take it seriously. And, luckily 99.9% of the time it's not. Maybe I should have said earlier, just, for the recording. In general, I think we do a great job of this as a project. And that's thanks to all of you. Everyone takes, hey, there's a bug in your CL. In general, people work very hard to try to avoid. We understand the responsibility of constantly updating the code that billions of people use for a large fraction of their computing. So thank you, all of you. But we still need to do better. What else? Yeah, this is an interesting example. This is just what the crash auto bug filer looks like, in case you haven't seen it. In general, one of the challenges we have with crash bugs is they might be security incidents. And if there's a security bug in Chromium, that's worth probably $1 million on the black market. So in general, we want to be careful about security bugs. But I think most of the time when a crash bug gets filed, anybody with edit bugs access should be able to see it initially. If it's determined to be a security issue, then it might get locked down further. And if it's determined not to be a security issue, we can make them fully public. But that's also something I'm interested to hear from non-Googlers about, if this is a problem in practice and do we need to adjust anything here. Yeah, so one of the nice things about the crash auto bug filer is it also does a culprit analysis and does a pretty good job of predicting what CL might have caused this crash. I can show you more about that soon. Oh yeah, this was an interesting case. Like, automation is great, but it's hard to have perfect automation. So in this case, crash was discovered in dev channel, and auto bug filer filed the bug. It's great, lots of time before it hit stable. And it got assigned to the author of the CL. Unfortunately, the author of the CL was on extended leave, didn't see the bug. And there wasn't enough checks and balances in the system to realize that, and this ended up escalating, became a P0 when this crash hit stable. This is one where we screwed up. The bug filer did the right thing, but we didn't have enough checks in the system to make sure that we actually acted on it before it was too late. Okay, and then a key step is actually reproducing the issue. You know, we can't always reproduce issues. We don't need to necessarily reproduce every issue. Crashes are a good example. Usually we can fix crashes without having to reproduce them. But in many cases, I've seen the difference between something being addressed very quickly and something dragging on for weeks is the difference between somebody being able to reproduce it or not. And so just if you get bugs assigned to you where, you know, they're saying something is wrong, there's some tricks we can use here. I mean, feel free. Sometimes we have problems with, you know, there's not enough detail in the bug. Sometimes it's internal systems. You know, sometimes there'll be some enterprise user that says, hey, we have this internal system that's broken. It's like, what the heck do we do with that, right? It's okay to like email people privately, ask them, can you give me test credentials to log into your system to debug this? You know, if we have to. One meta theme, people have probably seen that we're moving. We're more and more relying on experimentation systems, right? Running A/B tests with, you know, we call it Finch, and that's really good for making sure, like, really testing the impact of something, and that can really help product quality. But it really complicates this, right? At any given time, we might have hundreds of experiments running, and then you get a bug from someone saying, you know, it's misbehaving here, and nobody else can reproduce it. What the heck, you know? Who knows whether their particular combination of experiments are contributing to the problem or not. Something a lot of people maybe don't realize is we have this kind of hidden thing, and there's work going on to make this more visible, and the new bug template now points you at this. But if you go to Chrome version and then add a query string of show variations command, you get a big chunk in the Chrome version page that is the command line you need to run in order to start Chrome with the exact same experimentation configuration. And that can be super helpful. Someone saying, when I do this, I get this, and you say, well, I don't get this. What's the difference, right? Step one you got to do is make sure you're using the same variations. So here's an example that about, you know, the problems of reproductions. This was relatively recent. It was pretty serious. Anyway, ADFS, Active Directory, something or other, some kind of authentication, Microsoft authentication system. So this was a major enterprise that had a critical flow that was relying on ADFS. Unfortunately, it's not very common, and there was a not reached in some code that had been there forever, and we graduated that not reached to stable, to fatal, and it caused the network service to crash. And unfortunately, it was just so rare, like it didn't even have a blip in our crash metrics. It was like on the level of the noise that we see from like memory corruption and stuff, that like there was just no sign that this was, you know, something that should be taken super seriously. But what really went wrong here is there was a Google customer support team that was working with his partner. They filed an internal Google issue, but because what was happening, it was a network service crash, and so they were just getting like a spinner. Pages weren't loading. And the support people went back and forth for like 2 weeks, you know, trying to say, why is this thing just spinning? They uploaded some Chrome logs. The Chrome logs even contained in them fatal not reached, but no one realized the network service was crashing. And this is something like, if we had showed a SAD tab, we would have known right away that it was network service crash. We would have had the crash ID. And so finally, after 3 weeks, finally, a Chrome engineer got on a video call with the customer, immediately saw it was a network service crash, had the crash ID, and, you know, within a day, we had a fix merged out to stable. But this is just a really sad example of something that should have been able to be dealt with in a day, but because of the challenge of going back and forth trying to figure out how do you reproduce this crazy setup, you know, it took 3 weeks, which was really not okay. Next key step is bug triage. This means like actually setting the priority correctly, and not every bug is a P0, right? And this is tricky, right? Like we're a big product, we are constantly moving. If we come to the mindset that anytime anything goes wrong, it's a P0, our velocity is gonna grind to a halt, right? And it relies on kind of this shared culture of judgment, of trying to learn what things are urgent, what things are less urgent. And so hopefully you're aware of some of this already. I've got some links, we'll send out the slides afterwards. But we have labels. Release block is one of our most important labels that indicates the urgency of this, right? If there's a new issue that hasn't gone to stable yet, if it's regression, generally it's good to assume that this could become a serious incident, and then you can tag it with the release block label and say, well, we shouldn't even go to beta with this issue. It looks like it's potentially so bad, and it's okay to be conservative, right? And say, oh, this sounds like it might be, might become a serious issue. Let's tag it for now, and then we can always pull the tag off. But this is what gets our release team kind of gets it on their list, that they know that this is something that potentially stops us from releasing a new build of Chrome. And then we have a bunch of different, the key trick here is, in order to set the priority properly, you need experts who understand the space too, right? You can't do this automatically. So a lot of this is about fanning out. We're a big project. We've got thousands of people working on this project. And so we have things like the Blink bug triage rotation, where pretty much any bug filed by a web developer has an engineer look at it. I'm on this. I enjoy doing this. It gives me a sense of what our customers are actually experiencing on a regular basis. And the goal there is to just get, reproduction cases where we can, get things routed to the right people as quickly as we can. Make sure things are actually tagged as regressions if they're regressions, right? There's also it's a little bit harder now in Buganizer. I think we can do some things to improve this. Sorry, issue tracker. But there are the hot lists for marking something as a regression and saying what version it regressed in, right? And if things are tagged that way, then we can compute some stats on how we're doing about regressions. Lots of things go wrong at this stage. Sometimes it's really hard to know, is this an important issue or isn't it, right? Is this something one person is seeing on their machine because they have malware, right? Or they have faulty memory, or is this something that is going to be seen by a billion people? And then often there can be a lot of judgment challenges here. So, for example, here's one. Oops, this was supposed to be an animation. Why didn't that work? Oh well, whatever. This is one where I was on the Blink bug triage rotation. A bug came in that said that some website was broken, and broken pretty badly. And so I said, whoa, this is dev channel, raises my red flags. If we're seeing one site that's broken pretty badly, it's probably a big deal. I tagged it as release block stable, and we got it to the dev who made the change in this case. It was kind of complicated because this was a ICU issue, so it came kind of from a CLDR update. But then the dev who it came to just didn't have the same context of how webcompat works, and said it's a bug in the website. Website, needs to change, and just took the release block stable label off. This got it to stable, and we got a ton of reports from a ton of users about lots of websites that were horribly broken, and we had to do an emergency respin. Right? And so this is, and this is also in case you notice there was a month in between, right? I got CC'd on this and I didn't notice, right? I screwed up here by not realizing that something I'd said was important had been downgraded to not important when I was pretty confident it was going to be important. And then we wanted to determine what the cause of the issue was. And the best case here, it's so tempting to go in and debug and try to understand a thing in full complexity. But honestly, the most useful thing is to know what changed, right? And this is where bisection comes in. One of the most valuable things that we've got is our build bisect tool. Probably many of you have used it before. But one of the tough trade-offs with this is we have a build archive inside Google that's a Google internal archive that is Chrome built at every single commit, to the extent we can. Sometimes it doesn't build at one commit, so sometimes it's 2 or 3. But for the most part, it's built at every single commit. And once we added this many years ago, this seemed transformative to me. It means now when you get a bisect, it's not like, oh, something broke in this changelog of 50 different CLs. It's like, no, we know for sure that before this commit, it worked fine, and after this commit, it's broken, right? And then our principle of your commit, your problem applies. And it's like, okay, you're the one that broke this. You're on the hook to figure out, what to do about it. And normally the right answer is just revert it, right? Anyway, sorry, that's a future step. We'll get to that. Again, one of the challenges here is A/B experiments, right? If you're rolling something out by an A/B experiment rather than just by landing a CL, then it can be much more challenging to reason about. A lot of people don't know about this Finch bisect tool we have. So if you find you can reproduce something by using one of those Finch command lines I mentioned earlier, but you can't reproduce it without that, that's a great time to go use the Finch bisect tool and it'll basically go and say, okay, it happens with these 25 experiments enabled and not with them disabled, and then it'll just get you to reproduce it a few times, and it'll be able to tell you, oh, it's this experiment. And then you have the culpability, right? Culpability, knowing who broke it, is the most valuable thing to moving quickly in these kind of cases. So if you can do a Finch bisect and get it get it back to the owner of the experiment, then you're doing good. I think I got to go a little faster. Let's see what else. We're almost done. This is a quick example. Let's see, which one is this? Yeah, this is one where of a per revision bisect, right? That basically I exactly identified the commit. Hopefully many of you have seen this already. We have a test team that, if a bug is filed with repro steps, then our test team, usually within a day or two, will go through and do a bisect kind of automatically. You can also add the needs bisect label if you want to ask somebody to do this for you, and you can also do it yourself. But especially for people who don't have access to this per revision build system, if you add needs bisect, then a Google employee will go and do that, or a Google vendor will go and do that with access to that per revision system. And then we land a fix, and best case, we're able to get whoever reported it to very quickly verify that something will fix it. For example, turning off an experiment or setting a command line flag of some sort. Really powerful tool here are the Finch kill switches, right? We have a policy now. Anytime you're adding a new web API, for example, or shipping a new feature, we want it behind, like in Blink, you can use a runtime enabled feature. It's super easy to do if you haven't done it. You just put runtime enabled in your idle file or a couple lines of C++ code. And that sets everything up such that we can turn your feature off by deploying a configuration change rather than doing a rebuild. We can do that much faster. I forgot to add the link to this. There's Chromium flag guarding guidance that I'll put a link for onto the slide later today. And lots of things can go wrong at this stage. We can brainstorm more about this during discussion, I guess. And then eventually, hopefully, the incident is mitigated and we confirm with, ideally with our data that the problem has gone away, and or customers tell us the problem is solved. But we're not done yet. So, okay, incident's mitigated. This is one of the most important steps. Now, if it was a serious incident, we've got to do a blameless postmortem. We really got to reflect on it. What can we learn from this? If this type of thing happens again, how will we avoid it being as bad as it was? And so we have, we define some SLOs within Google. We want to try to get these done in about 2 weeks, and we want them to end with some P1 bugs that we commit to taking some action on, even if it's just a small step in a better direction in the next 4 weeks. As P1 bugs generally we want resolved in 4 weeks. There's lots of ways this goes wrong. I've seen so many postmortems where it's like, well, we brainstorm about all these giant things we could do, and we file a bunch of P2 bugs of wouldn't it be nice, and nobody ever does any of them. It's like, oh, what the heck did we do this postmortem for, right? So we try to really focus on what are some concrete, specific things. We don't need to solve the whole world. How do we get a little bit better based on what happened this time? And we have a bunch of tooling inside Google. None of this is exposed outside Google. We can brainstorm about that, but we have, we have SLO tooling that warns you if you've got an issue that's postmortem is past due, nags people like me to review the postmortems. And then, best case, we actually complete some action items that reduce the risk of this kind of thing happening again in the future. So we get, we have these P1 issues and they're fixed within a month. And next time, hopefully an issue is less likely to happen. One of my favorite examples of this from last year was we had a couple different major incidents that were caused by upgrading a D check to a check, and more recently making not reach fatal. These are complicated. I think we've made mistakes here. We're going through some reviews right now and reevaluating how we approach this. But I really do believe that in the long run, we have a more reliable product when we have stronger invariance. This kind of came to a head after we had a couple incidents where the takeaways, people were saying, oh, this guidance to use checks is just wrong. We just got to stop using checks. We just got to be way more permissive in allowing things. And that, yes, that might help avoid the immediate incident, but it creates a product that's going to be less reliable in the long run, right? More data corruption, that sort of thing. And so I was very worried that, we were going to backslide on that long-term product quality in the interest of short-term crash reduction. And a bunch of us talked about it. We came up with this pretty elegant middle ground that hopefully you've all seen this not fatal until. If you're going to add a check or a not reached, you can just add an argument that says not fatal until M134. And then what happens is we get all the crash reports prior to 134, but we actually just continue running. And then the idea is those crash reports, if they're serious enough, should get bugs filed against them. We should treat them seriously and get them fixed. But if we don't get any, or we get only this very low volume of crash reports, then it upgrades automatically to becoming fatal without you having to go back in and say, oh, this can become a check now. And I think this has worked out pretty well for us. It's not perfect, but this was exactly an action item from there was one postmortem that we didn't think of this, and then we had another postmortem that was a similar root cause, and we're like, oh, we got to do something. And this came out as an action item, and we've done it, and I think we're better off for it. Okay, so lots more we could discuss. I'm at my time, so sorry this was a bit of a brain dump, but I hope this sets a framework by which we can all brainstorm together about how to try to improve. Love to hear people's thoughts. We've got Bobby's World booked for people who want to dive into this, but we can continue the discussion. Chromium Dev, Blink Dev. Feel free to reach out to me privately, and we thank you for your thoughts. Let's work on making Chromium higher quality together.